So in this video we'll be finding the REF and RREF of a matrix. So let's start with the two conditions that REF has to fulfill. So the two conditions are that the leading entry, also called the pivot, of a non-zero row is strictly to the right of the pivot of the row above it. And the second condition is that if there is a zero row matrix, it has to be all the way down. So let's just look at these examples, which will be more clear to understand. So the first matrix, we have it 3 by 3. So we look at the first non-zero number in the first row, which is going to be 7. So this is the pivot of the first row. The second, so now if there is a number below this pivot, let's say if there was 1 here, 0 is not a pivot, so it cannot be that. So these are two zeros. So let's say if this was 1 here, so that will violate the first condition. So here we look down and to the right. So this is next pivot now, and then again down to the right and this. So now let's just take this example. Let's say if there was 1 here. So now this will be the pivot actually, because this is the second non-zero number in the second row. So then it will not be REF. So yeah, so it's very simple to understand. So this is REF now. Oops. So let's move on to the next example. So again, find the first non-zero number in the first row, which is -12. Now we look down and to the right. So down and right, this is the next pivot, and this is violating the first condition that there is a number below the pivot. So this is the number below it, and as you can see there's a 9 here, but it's not to the down and right. We have to look always down and right. We have to go diagonally like this. So this is not REF because of this 8 here. So now let's say if this 8 was not here, and let's say if there was a 0 here, then it will be REF, since it is fulfilling the both conditions, that the 0 row is all the way down and the other is that there is no number below the pivot. But since that's not the case in this example, this is not REF. Now let's look at the next one. So first non-zero number in the first row is 6. Now we look again down and right, 7, and we have a 0 row at the bottom. So this is REF now. Oops. Now moving on. So we can see that there is a 0 row at the top. So this is violating the second condition, which is that if there is a 0 row, it has to be all the way down, like the last example. So this is not REF, this means. So let's say if this 0 row was at the bottom like this, 1 0 0 -5 and 0 0. This REF, since the first pivot is 1, second pivot is -5, and there's 0 row at the bottom. So this would be a REF then, but that's not the case here. Okay, moving on. So in this example, we have the first pivot, which is 1, and then these are just zeros. So this is REF. The second example is the same. The first non-zero number is 1 here, which is the only pivot, and there is no number below it, and it's not violating any conditions. In the third last example, we have 1. So this is the first pivot, and if we look down and to the right, this is the next one. This is the second pivot. So it is REF. The last example is REF. And again, you do not look to the right. These are not pivots. If there's only one pivot in every row. And now let's see how to convert a matrix into REF. So there are three methods to convert a normal matrix, let's say a non-REF, not REF matrix into REF, which are interchanging rows, scalar multiple of a row, and the most important one which we use a lot is adding a scalar multiple of a row to another row. So let's just look at some examples which will be more clear to understand. So here we have a 3 by 3 matrix, 1 2 3 4 6 8 and 0 5 3. So the first thing again is finding the first pivot in the first row, which is 1, and we have a number below that pivot which is 4, and below that is 0, so 0 is fine and 4 is there. So first thing we can do is that we can convert this, we can use the first scalar multiple of the first row, which will be minus 4 r1 plus r2. So we are adding minus 4 times r1, which will be minus 4, which will cancel the 4 out, and the other ones, let's see, and this will cancel this 4 out, so it's not violating the first condition. So we get, the first row will stay the same, second row is 4 minus 4, which is 0, 6 minus 8, which is minus 2, 8 minus 12, yeah, so minus 4, and then we have 0, 5, 3. Now we can see that the first pivot is fine, there's no number below it. So now moving on to the next pivot, which is minus 2, and below that is a 5. So we can see that we can use the second condition here, which is scalar multiple of a row, to divide the second row by minus 2 to make it 1 and 2, and that will be more easier to minus the 5 then. Since right now if we do the scalar multiple, it will be in fractions, and that is very hard and very confusing. So next step we can do is we can divide the second row by minus 2, which will give you, first row is the same, second row we are dividing by a negative half, it will give you 1 and 2, and last row stays the same. So now this last step, which you can see that we can use the second row to minus the 5, since this is violating the first condition of REF. So again we we can do minus 5 r2 plus r3, which will give us, first row stays the same, second row also stays the same, third row is 0, 0, minus 10, and it will be minus 7. So if we check the pivots now, we get there's 1 here, next pivot is 1 again, and last pivot is minus 7. So in this example we have a 4x4 and we want to convert this into REF. So first thing, again, we need to look for the first pivot in the first row, which is 3. And so this is a best practice to keep the first pivot in the first row 1, since we will be using this to minus this 2 here and this 2 also to make it 0. So we can see that the first row is a scalar multiple of 3, since it's 3 minus 6, 9, 3. So first step we can do is that we can divide the first row by 3. So it will be 1 over 3, oops, don't mind my handwriting, 1 over 3 r1, so this will give you 1, negative 2, 3, 1, and everything else stays the same. Now we can use the first row to minus the 2's down, so it will be minus 2 r1 plus r3, and same thing on minus 2 r1 plus r4 to make them zeros. So now this will give you, so the first row stays the same again, second row is also the same, third row is gonna be 0, 10, minus 5, 0, and last row is 0, 0, 0, minus 1. And now we can see that this, again, if I highlight the pivots, this is the first pivot, this is the second pivot, and there is a number below it, we can use this one to minus this 10. So now let's do that. So let me just write it down here. So we can use minus 10 r2 plus r3, and this will give you First row is the same. Second row is also the same. Third row is going to be 0, 0, minus 15, and then minus 10, 10. And last is just minus 1. So this is REF now. If we highlight the pivots, this is 1, second one, third one, and fourth one. So let's do one more example. So in this example, we again have a 4 by 4, but this time there will be a 0 row. So just to familiarize you with that. So let's start with the first step. First pivot is 1, and this is the best practice to keep it 1, so it will be more easier to minus the ones below it. So let's do that step now. So it will be R1 plus R2, and then 3R1 plus R3. This is a 5 here. If you cannot, let me make that clear. And then last step is minus 4R1 plus R4. So let me just do this now. Again, new first row stays the same. Second row will be 0 and then 5. So we are plussing R1, so minus 6. And then the last is just 5. And for this one, it will be 0. And here we are doing 5. Here it will be minus 6. And last one is 5. So we can see that they're two similar rows, same rows. And last one is 0, 4, minus, so it will be 2, since it's 6 minus 4. And last one is minus 2, minus 4, so minus 5. So let me just bring the 0 row down. So now it will be, if we do R2 minus R2 plus R3, so this will be a 0 row. So let's just bring it down. We can flip it with this row. So let me just do that right now. We are flipping R3 with R4. So let me just do this step now. 1, 1, 0, 5, minus 6, 5. Now we are doing this 0, so there's a 0 row here, and we're flipping it with this one. And then last thing is 0 matrix row. Now we can simplify this more. So sometimes there is no way to avoid fractions to make the matrix into fractions. So here what we have to do to make this 4 0, we need to times a multiple of the second row to the third row. Since this cannot be, this pivot here cannot be converted to 1, so we'll use that. So what we can do is a very simple step, which is going to be, we are going to do minus 4 over 5 times R2 plus R3. Since 5 times minus 4 over 5 is going to be minus 4, so we'll cancel this 4 out and we can do the rest. So now this will give you 1 0 1 1. Let me just make that, yeah. Second row is also the same. Third row is going to be 0 0. Now you can use a calculator to do minus 4 over 5 times minus 6 plus 2, which will give you, let me type that on my calculator, 6.8. And then the last thing is minus 9, and then we have 0 0 0 0. Let me just make this, yeah. So this is the final answer. You can notice that we have a fraction or decimal, and this is a 0 row at the bottom. And let's say if the 0 row was at the top like this. So same example. 0, oops, and then we have all this again. Let me just write it quickly. -5, and then we have actually this one here will be here, and here will be this one. Yeah, okay, my bad. So this one will be here. If you're flipping it, it will be more easier, but you get the idea. So if it was if you've got this as your final answer, the last step you have to do to make it into REF would be to flip this row, first row with the last row. So that will bring the 0 row at the bottom, and you have REF then. So now let's move on to RREF, which stands for reduced row echelon form. And the two conditions are for this one is that it is if it is in RREF, this means that it is in REF, but it's not vice versa. And the other condition is that every pivot has to be 1, and there cannot be a number above it and below it. So basically there's only one number, which is 1, and it is the only number in the column. So let's look at these examples I wrote here, which will be more clear to understand. So the first pivot in this matrix is 1, and if you look down and to the right, this is the only pivot here. This one is in RREF, since it is fulfilling the both conditions, which are that the pivots are ones. It cannot be like a number like 2 or something. Then it will be REF. And the other condition which is very important is that there cannot be a number above it and below it. So that's a trick. So let's say if there was a number here 6 or 3 or whatever, then this will be REF. But since there is no number above it, that means that it is in RREF, sorry, I keep confusing them. Yeah, so first is this. Now let's look at the next example. First pivot is 3, so you already know it's not RREF. And next pivot is 1, and this is here 1. So this is in REF since there is a 3 here. And we can convert it into RREF by just dividing the first row by 3, and that will be RREF then. Next example, first pivot is 1, and if you look down into the right, this is next pivot, and that's it. So this is our REF since both the pivots are 1 1, and there's no number above it and below it. So EF. Next example, so there's a 1 here and there's no number below it and to the top also. So this is also RREF. And the first thing I said was every matrix which is in RREF is also REF. So if it is RREF, then it is already REF, if that makes sense. So we can also say this is in RREF and it's in REF. Next example, there's a 1 here, and if you look down into the right, there's a next pivot and there's a 0 row in the last. So this is in RREF. And last example is this is the first pivot, which is 1, second pivot, which is also 1, and there's a 0 row at the bottom. So this is also in RREF. So now let's look at how to convert matrix into RREF. So we have a 3 by 4 matrix here, and we want to convert this into RREF. So first thing we can see is the first pivot is 3, and we cannot divide this. This is not a scalar multiple of anything to make this into 1, but we can see the second row is 1 negative 1, and this is the pivot of the first second row. So what we can do as a first step is to switch the first row by the second row to make it more simpler for our lives to convert into RREF, of course. So it's gonna be 3, 2, 4, 1, and last. Don't mind my handwriting. I know. Yeah. So now we can use the first row to minus this 3 here. So it's gonna be minus 3 R1 plus R2, which will give you, first row stays the same, second row is gonna be 0, and then 5, 4, 4. Third row is gonna be 0, 0, 4, 0. So now if you look here, we have first pivot is this, second pivot is 5, which we also have to convert into 1, since every pivot has to be 1 and there cannot be a number above it and below it, remember that. So to do that, we can divide the second row by 5. So this will give us 1 over 5 R2. First row is the same, second row is 0 is 1, 4 over 5, and then 4 over 5 again, and third row is gonna be 0, 0, 4, 0. Now what we can do is we can add we can also, one quick step we can do is 1 over 4 R3, which will convert this 4 into 1, make it more simpler. Yeah. And next step will be to minus the ones above the pivot. So what I mean are these numbers, this number and this number, because they cannot be a number above the pivot and below the pivot for RREF. So to do that, it's very simple. We can just we can use minus 4 minus, first of all let's get rid of this minus 1 here, so it's gonna be R2 plus R1, yeah, R2 plus R1, which will give us, let's do it step by step, 1, 0, it will be minus 4, no, 4 or 5, and then minus 1 over 5. You can use the calculators for this. Let me just move my handwriting here. And second row is the same, 1, 4 or 5, and then we have 4 or 5 again, 0, 0, 1, 0. So now we can see that above this third pivot there's 4 or 5 and there's another 4 or 5, so we have to get rid of both of them. And to do that, it is again very simple. We can do yeah, we can do minus 4 over 5 R3, and then again plus R2 R1, first of all, 4 over 5 R3 plus R2, and this will be the final answer now, which is gonna be, first row is gonna change into 1, 0, 0. Use a calculator for this, or you can use your mental maths. And its second row is 1, 0, 4 over 5, minus 4 over 5. Oops, it's not minus 4, 5. Yeah, be very careful. If you make a silly mistake like me using your mental maths, you will get the wrong answer. So now if we check the pivots now, first pivot, second pivot, and third pivot, and again the condition is that there's no number above it and below it, so that is fulfilling it. And yeah, so let's look at one last example, I believe. Yeah, one last example. So here we have a 3 by 4 now, and let's look at the first row and the first pivot. It is 2. It has to be, every pivot in RREF has to be 1. So is there any way we can convert the first row in the first pivot to 1, we can divide the first row by 2, which will give us 1 over 2 R1, which is 1, 4, 2, 1, and then everything else stays the same. 4. Now this is very easy since we can use that 1 to get rid of the ones below the pivot, which are 2 and 4. So we can do minus 2 R1 plus R2 minus 4 R1 plus R3, which will give us, first row stays the same, 2, 1, and we can do 0 minus 3. Again, be very careful when you're doing this mentally, or use your calculator if you can. And last row is 0 minus 6 minus 9 minus 9, and then minus 3. So one thing again, next pivot of the second row is minus 3, and we can see that we can divide the entire row by minus 1, and the pivot has to be 1, not minus 1. Be very careful of that mistake also. So we can divide the second row by minus 3. So let's do that. Minus 1 over 3, don't mind my handwriting, or 2, and will give us 1, 4, 2, 1, 0, 1, 1, minus 1, and then last row also we can divide by minus 3. It's fine, we can just use this to, yeah, let's do it step by step. So one last step is that we need to get rid of this number now, minus 6. So we can do 6 R2 plus R3. It's very helpful to write these the calculations you're doing if you want to recheck your answer, because you are very prone to silly mistakes when you're doing this. So it will be 1, 4, 2, 1, 0, 1, 1, minus 1, and last row is going to be 0. We can do also, yeah, 0, 1 second, yeah, 0, 0, minus 3, minus 9. We also have to get rid of this 4 above it, so we need to do minus 4 R2 plus R3, sorry, R1, my bad. So it is going to be 1, 0, minus 2, 5, and everything else stays the same. That is not a 6. We can just do one more step here, which is minus 3 R3 to convert this into 1 and 3. So now if you look at this, your pivots are 1 and 1. There's no number above and below this, but there, the third pivot, which is this one, is the number above it, and this first row also. So we need to get rid of that, and that's our final step, which will be the calculation of R3 minus R3 plus R2, and then there is 2R3 plus R1, which will give us the final answer of 10011. Again, I'm saying this, be very careful when you're doing these calculations, because one silly mistake will mess up your answer totally. So this is the final answer. Now to recheck, we can find the pivots and see if it fulfills the conditions. This is the first pivot, this is the second pivot, this is the third pivot, and it is not violating any of the conditions, which are that there's no number above it and below it. So basically in the column there is only one number, which is 1, and there cannot be anything else. So there's only every pivot is 1, and it is the only non-zero entry in the entire column. And for this it does not matter since it is not violating the conditions. So that's all for this video, and I'll see you next time.